Hello everyone. Here I'm going to talk about two principles of the mathematical law of large numbers. Now, the law of large numbers is used to make predictions for either like auto insurance or banking or gambling or medicine or playing cards, anything really. And so basically what the law of large numbers does is it tells us and allows us to make a few predictions based on the past events are, and it all really circles around what our expected mean is, what our expected observed probability is, and what happens is our observed probabilities over time will reach our expected probability. So basically what this does is we can make predictions and have confidence in our predictions. Let's take the exercise of flipping a coin. Now, if you flip a coin, if it's a fair coin, you're going to get a 50% chance of heads and 50% of tails. So if you're doing a million coin flips, you could say that the expected outcome or probability would be 500,000 heads and 500,000 tails, which would be correct. What the law of large numbers says is as our samples increase, we are eventually going to get closer and closer to that expected value. So let's just say, for example, let's just take in this case we're doing a few coin flips. Now notice what happens to the mean. Let's just say our first coin flip is tails. Our second one is tails. Our third one, if we flip it again, is tails again. So if I flip another coin and it's heads, what we're doing is we take the one head by 4 chances, and we get exactly how many percentage of heads and tails we have. So notice how our running probability kind of hits and goes around our theoretical probability. So basically, over time, our coin flips will gravitate towards the mean until, like I said in my example, if we had 1 million of them, eventually we'd get to like 500,000. Now, this isn't really what a lot of people call the gambler's fallacy, which means if you get 4 tails in a row, then the next one has to be a heads, right? Well, that's not true either. The law of large number just says that over the longest period of time, as our sample attaches our population, we're going to get towards, if not meet our expected value. Now, we can also take a look at one more aspect of the law of large numbers. What I showed you before is, our running mean will always kind of gravitate around our expected mean, and eventually it will hit it. Now, another principle of the law of large numbers are eventually our sample average will meet our population average. Let's just say, for example, I have 100 people, and I know the 100 people have a mean of $50 in their wallet. So I go to one person at a time. Remember, I know my population mean is 50, but I'm going to go one at a time. First person says I have $49, and I'm going to kind of average that. Second person has 29. I'm going to average that. And then I'm going to go on and on, not the third person, the fourth person, the fifth person, and so on. So as my observations approach my population, my running mean will eventually hit my population mean. So those are the two aspects of the law of round numbers. It also has a lot to do with randomness as well. Randomness is going to be a topic for another video where I'm going to talk about taking large sets of numbers and determining if they're random or they're not. Now remember, the law of large numbers is just basically a principle saying over time these two principles will be true. One is that we will gravitate around our mean and eventually hit our mean, and the second, we will our sample mean will eventually hit our population mean. Thank you and have a good day.